Hello students, hope all is well from your sides. In our previous class we have completed exercise 3.1 and today we will start our new topic trigonometric functions. Okay, now see, in our previous class we have studied trigonometric ratios for acute angles as the ratio of sides of a right angle triangle. Now see, we will study about trigonometric ratios to any angle in terms of radian measure and study them as trigonometric function. For this, what we have to do, we will consider a unit circle with center at the origin of the coordinate axis. Okay, let PAB be any point on the circle with angle AOP is equals to x radian, that is length of arc AP is equals to x. Okay, now see, we define cos x is equals to A and sin x is equals to B. Since triangle OMP is a right triangle, we have OM square plus MP square is equals to what? OP square, or we can say that here A square plus B square is equals to 1. Okay, or we can say that here A square plus B square is equals to 1. Okay, thus for every point on the unit circle, we have what? A square plus B square is equals to 1, or at the place of A square. So at the place of A square, what we will write? Cos square x plus sin square x is equals to 1. Okay, since one complete revolution subtends an angle of 2 pi radian, that we know that. Okay, since one complete revolution subtends an angle of 2 pi radian at the center of the circle, so here angle AOB, how much? Angle AOB is equals to pi by 2. Okay, now see here, and angle AOC, just you see, angle AOC. So by seeing the figure only, you can say angle AOC is equals to pi and angle AOD is equals to how much? 3 pi by, and angle AOD is equals to how much? 3 pi by 2. Is that okay? Now see here, all angles which are integral multiple of pi by 2 are called what? Quadrantal angles. Okay, all angles which are integral multiple of pi by 2 are called quadrantal angles, and the coordinates of the point A, B, C and D are respectively. Now we can write it, the coordinates of the point, the coordinates of the point A, B, C and D are respectively what? Are respectively, just you see the figure and tell the quadrants. So A 1 0. Okay, so here A, how much? 1 0, we can write 1 0. Okay, B this much 0 1, B 0 1, B 0 1, C that is minus 1 0, minus 1 0, and D how much? And D how much? 0 and minus 1. Therefore, for quadrantal angles, we have here, so for quadrantal angles we have cos 0 degree is equals to how much? 1, and sin 0 degree is equals to 0. Thus for quadrantal angles, cos 0 degree is equals to 1 and sin 0 degree is equals to 0. We know that cos pi by 2 0 and sin pi by 2 is equals to 1. Again, cos pi is equals to minus 1 and sin pi is equals to 0. Okay, now see, cos 3 pi by 2 is equals to 0 and sin 3 pi by 2 is equals to minus 1. Cos 2 pi sin 3 pi by 2 is equals to minus 1. Cos 2 pi is equals to 1 and sin 2 pi is equals to 0. Okay, so we take one complete revolution from the point P. We again come back to same point P. Thus, we also observe that x increases or decreases by any integral multiple of 2 pi. The value of sine and cosine functions do not change. Thus, we can say that sine 2n pi plus x is equals to sine x, n belongs to z. Okay, and cos 2n pi plus x will be equals to how much? Cos x for all n belongs to z. Okay, now see, so we can say that sine x is equals to 0. We can say that sine x is equals to 0 for x is equals to 0 plus minus pi plus minus 2 pi plus minus 3 pi and so on, where x is an integral multiple of pi, and cos x is equals to 0 if x is equals to plus minus pi by 2 plus minus 3 pi by 2 plus minus 5 pi by 2, that is cos x vanishes when x is an odd multiple of pi by 2. Okay, so we can say that sine x is equals to 0 implies x is equals to n pi, where n is any integer, where n is any integer. Okay, and cos x is equals to 0 implies what? X is equals to 2n plus 1 pi by 2, where n is any integer, where n is any integer. Okay, so this much for this class, and we will discuss more thing in the next class. Till then, have a good day.